Hello, everyone. I'm Janine Donnelly, Director of Webinars for Tech Channel, and I'd like to welcome you to our presentation, Access, Analytics, and AI, the 3 A's of mainframe data demands. Today's webinar is sponsored by Software AG. And now I'd like to turn it over to Bob Jeffcott, Principal Systems Engineer at Software AG, to kick things off. Bob, you now have the floor.
Thank you, Janine, and thank you everyone for attending our session on mainframe data access. Today we will be explaining the importance, methods, and challenges of making mainframe data easily accessible for use in analytics and AI. I have with me Michael from the state of Delaware, who will discuss their success with opening up their mainframe to a wide variety of applications, and my colleague Dimas, who will be demonstrating AI in action utilizing mainframe data. For a long time, often decades, the mainframe has been the center of the IT enterprise, performing core business functions. But as technology has expanded, so has the IT landscape. More and more demands are being placed on the mainframe to provide more and more data, and that pace is only increasing. Initially, those requests were well defined. I need a dashboard, move this data to a data warehouse, and infrequent. We're implementing a new ERP package. We have this web application that we need data from the mainframe. But now those requests are less defined. Hey, I have this data lake and I need all your data. Or give me a stream of data for my analytics tool that we just bought. And more often, hey, our corporation just switched cloud provider, new data lake. We have this cool new AI engine. We have this new low-code, no-code application. Oh, and we've made changes to it. So a lot of those requests are much less defined and much more urgent. But like those demands, more and more demands are being placed on the mainframe staff, often with less and less resources to perform those normal day-to-day tasks. The mainframe data is often perceived as hard to get to, the application's slow to respond to these new pressures. This is sometimes a driving factor in replacing the mainframe applications. But those applications often and typically provide functionality tailored to your specific organization's need with a wealth of data that cannot be easily replaced. Today, we will look at ways to make the data more accessible, more usable, while reducing the time to provide it, and while maintaining business continuity. Part of the challenge of providing data to those external entities is the inability to communicate what they need and how they need it. And let's face it, data in mainframe is not often stored in the most user-friendly formats. As we mentioned previously, some of those applications are decades old and were built with limitations that no longer exist, but the applications have not been modernized to leverage those new capabilities. So we have data challenges, things like codes that need to be translated into meaningful, usable data. Multiple types of information are often stored in the same fields, especially with things like VSAM, where a record type says, well, if it's this record type, this is what the data means. Otherwise, if it's this record type, it means this. Data type translations. And we're not talking just EBCDIC to ASCII, but mainframe data formats like packed, binary, date, time translations into whatever that target format needs to be. And we often, the table names, the field names are not in the most user-friendly format, and they're not really documented well often. We also have the other challenges like adhering to security requirements, both on the mainframe and on the enterprise. Getting that non-relational database into a relational data format that those targets can understand. Timing of requests for data. Different targets have different demands, and lack of skills and resources. Mainframe resources are dwindling, plus you don't necessarily know and understand all those new the new platforms. And lack of understanding requirements are for those external applications. Let's look at your current approaches to address these demands. We have data warehouses, there's dashboards probably, there's reports, Excel extractions, but the challenges still exist, especially with these new pressures. One is do nothing. And by do nothing, we don't really mean do nothing. You guys have addressed, I'm sure, data extracts, data access to external things. But basically what I'm saying is do nothing new, keeping the status quo. You know, we often hear that term, keeping the lights on, meaning just making tweaks to the existing processes, but no new real data initiatives. There are custom builds, and those have challenges, both from a data perspective and from a resource perspective. And those custom builds take away time from your already limited resources. And there are point-to-point integrations, you know, connecting mainframe applications with some new systems of engagement. But there are challenges with that. Those are constantly changing, new applications, new APIs, new data requests. And again, that's removing those resources from doing their day-to-day job. And there are costs associated with those slow to respond methods. In today's world, data has really become king. Again, demands on all sorts of data, and that mainframe has a wealth of data. And there are more and more resources to utilize and analyze that data. More and more people are using those tools because they're user-friendly, easy to use. But there is a cost for providing inaccurate, incomplete, or outdated information. And in this slide, they use the term data scientist, but really we mean anyone that is using data to make business decisions. And multiple studies have shown that making those decisions based on that inaccurate, outdated, or missing data are costly. And oftentimes those challenges are due to multiple copies of the same data in different formats at different points in time. There's no real single record of truth. And let's look at some of the scenarios that's required in ways to ensure that it is timely, accurate, and understandable delivery of that mainframe data. First, we need that data to be easily accessible, and by someone other than a mainframe programmer. It needs to be in an easy to understand format. We can't just use those kludgy, hard to understand names of the tables of the field names. And there needs to be metadata that a non-programmer, non-mainframe programmer can understand. User-friendly names, codes are translated, the right formats for the right delivery, addressing all those challenges that we talked about earlier. And of course, all while maintaining those security requirements. Second, that data needs to be accessible in a format that provides easy visualization. That typically means sufficient volumes of data delivered effectively and efficiently while not impacting the mainframe resources. You don't want the lights to dim every time you need a visualization of some data. And it has to be self-serve for those users of that data visualization tool. They can't constantly be bugging the mainframe resources for that. Because those visualization tools change, the requirements for the data that they're using change. We need that available without mainframe developer intervention. Third, the data needs to be able to be joined with other data sources. We talked about that incomplete or inaccurate view of data. The mainframe data needs to be combinable. I don't know if that's really a word, but needs to be combined with other data sources. Again, without that programmer intervention, and oftentimes without the end user even knowing the underlying data source. And lastly, sometimes that data does need to be replicated, but that does cause challenges. Now you have multiple versions of it. So that data needs to be only be delivered in the right format using the right connection, because it could be delivered to different data sources. But you need to be able to track that data replication to ensure that there is truly a single version of the truth. That means tracking when and where that data was replicated. And it needs to be, this replication, the ability to have multiple schedules. Some have daily, some have hourly, some have almost on demand. Multiple translations. That data from the mainframe might need to be translated into data, multiple data sources, have multiple different data targets, and all while maintaining that tracking so we ensure that it's easy to understand when and where that data was moved. Now let's see how our Connects tool provides that capability. Connects platform provides connectivity to over 150 different data sources, not only to the mainframe, but to AS400s, OpenVMS, and a wide variety of Linux, Windows, and cloud-based data sources. This gives you the ability to deliver all the data requirements by your organization quickly and easily, all while providing the necessary levels of security. The heart and soul of this platform is our metadata repository, the data dictionary. This provides the ability to deliver multiple views of your data source in user-friendly formats. You can have multiple different metadata views for the same underlying data source. This provides the capability of providing different perspectives for different users. They get to see the information they need in the format that they need to see it in, and ensuring that the security requirements are still met. And you can provide logical views of the data, making multiple data sources look like a single table, simplifying that access. And there's those stand without really needing to understand the underlying data source. And really, when data movement is required, platform, it provides scheduling and tracking of that data movement, so you know when and where the data was moved. It provides seamless connectivity and movement to the target data platforms such as Snowflake and other cloud platforms. With that, I would like to turn it over to Michael from the state of Delaware to talk about their success with the implementation of this platform. Michael?
Thanks, Bob. So, good afternoon. My name is Michael McGuigan, and I work with the Delaware Criminal Justice Information System. I'm the platform engineering manager, and we write much of the modern software that the criminal justice system uses. Our agency has been around for over 30 years, and we're very blessed to be one of the only states in the country with a single centralized system of record. Long ago, some very smart people got together and decided that it would be a wise decision when computers really first started taking off to create a single criminal justice system that all law enforcement, the courts, the corrections system would all use together. And now we've grown to the point of having over 400 partners that integrate with us. As the single source of record in the state of Delaware, we integrate with virtually everybody who has a criminal justice need in one aspect or another. We have been a historic mainframe customer for much of those 30 years. We have over 18,000 programs written in Natural that build the foundations of the criminal justice system. Like other entities, we get the call for modernization. And when you have 18,000 applications, you have to address modernization in a pragmatic way. So we can't just rip our systems out and rebuild them. So we have to address the constant changes that come with a legislative season or regulatory requirements, reporting requests from all aspects of government, both at the federal level, state level, partners, we have to address all of these needs while maintaining our security, maintaining our existing foundation without ripping all of that out. And we have to do it with the workforce that we have. One of the issues that every mainframe shop often feels pain on is reaching out and hiring new mainframe resources. It can be a challenge. What we do in our agency is we tend to bring people on and train them on the job. They come into, for example, my platform team, and they learn a lot about mainframes when they come in. But over time, that's gotten easier thanks to tools like Connex. So our approach to mainframe modernization really has been to rethink what we consider the mainframe. As opposed to thinking of the mainframe as a large time-sharing system that everybody is writing software on and is sharing time on that system, we treat it like a database. And Connex enables us to do that by allowing us to access it through simple SQL. So by doing this and by rethinking this as simply a database, we're able to kind of change that mindset from those who would see modernization as get rid of the mainframe. Because for us, it's simply not a practical thing to do. We have so many integrations in those 18,000 programs. So instead, we're able to build on top of that foundation that we already have. And Connex allows us to address a very serious skills shortage that exists in the mainframe world and bring people in with top level talent, but they can on the job learn technologies that they might never otherwise get an exposure to. So I'd like to give an example of that. One of the projects that my team is working on right now for the state of Delaware is called FTAP. FTAP stands for the Firearms Transaction Approval Program. In the United States, if you purchase a firearm, you're going to get a background check performed at that purchase. Usually, someone's going to fill out an ATF 4473 form, and someone's going to make a phone call or use a computer or something like that to go ahead and verify whether or not you're lawfully able to complete that purchase. And usually it's a pretty quick process, depending on the state and where you live. Sometimes in some states, it's 5 or 10 minutes. Many states, these requests go to the FBI, and they process these requests quite efficiently, and they get the answers back. But then there are other states known as point of contact states, wherein they enhance and augment these things with their own state requirements by becoming the point of contact for these background checks. And that's what Delaware is a point of contact state. So we're developing our state's new firearms transaction approval program. So that way we can be a little bit more thorough with the background checks and ensure some state laws and things like that are adhered to, and make sure that we maintain all of the forms of compliance. And as you can imagine, this is, to us, a very critical system. It's a very large project. We integrate with a number of data sources. And by integrating with all of these different data sources from both the federal side, from the state side, we're able to try to meaningfully make sure that we're checking people accurately and effectively. We do this with, as a small agency of a little over 35 people, and we have about 6 major experts on the mainframe in our team. But this is a very modern system that we developed. This is a .NET 8 system, and we wanted to bring on quality talent to be able to work on this system, talent that has a history of making successful products that are accurate, most of all, and are reliable. And we'd hate to deny people the position simply because they don't have mainframe experience. And thanks to Connex, that never had to be a concern of ours with this particular project. The folks working on this project right now came into our agency with virtually no mainframe experience. they know that they are working with a mainframe. We've told them this and things like that. But as far as it goes to them, they're working with standard ANSI SQL. They're writing standard SQL queries, and they're able to work through our data sets and perform those state and local checks, and as well as integrate in with other things like federal checks. It's very easy for them to work through this. So we're able to hire the right kind of talent to build systems like this and to do this in a safe manner with high quality talent. This is one project out of dozens or more projects that are underway. But our main goal is to modernize CGIS and has been. One of our largest goals kind of kicked off in 2019 with the plan to change our way of working with the criminal justice system from being batch oriented, which is common in so many mainframe shops, right? You know, we all have batch jobs that run at night and things like that, into a real-time system where when an event occurs, we can react to it in software quickly, and we can alert the stakeholders of that data quickly. A good example I tend to give people is like an arrest warrant process. You know, an officer requests an arrest warrant, and you know, maybe a notification goes out on a schedule to somebody, and then they handle approving or denying it, and then another schedule may determine when somebody gets notified of it. Well, we don't want it to be on schedules. We want it all to be real time. So one of the goals that we've been working towards is as the data changes, we react to the changes. The software can heuristically know, okay, a new arrest entry was entered. Okay, so now I can react to that and I can subscribe to that and I can kick off the process of what needs to happen after an arrest. Or a new arrest warrant was denied. I can let an officer know, hey, your arrest warrant was denied. You need to change something about it, or et cetera, et cetera. So one of the ways that we're doing this is kind of twofold. One, we're working on an event stream system with our mainframe, and two, we're integrating tightly with Connex. Connex, through its exposure of SQL and the ability to easily get access to our data, allows us to react to these events and pull down all relevant information about these events and publish them to a message bus that the applications can then subscribe to and react to in real time. So we end up with a law enforcement message bus. And that's really what we're looking to build in this kind of next generation of our criminal justice system, standing on top of the shoulders of what we already have today. And in terms of standing on top of the shoulders of new technology, I want to hand over to Demos because he has some amazing new technology to show.
So good. Hello, everyone. My name is Demos Economarcus. I'm a pre-sales engineer with Software AG based on the West Coast. Today, I'm going to talk to you about how you can use artificial intelligence with legacy mainframe data. As mainframe experts, we deal with an enormous wealth of data that is often siloed in legacy systems that are integral to business operations. By using data access and integration tools such as Connex, we can easily access siloed data, enabling it to be processed and analyzed with the capabilities of large language models such as OpenAI and other AI-based analytic tools such as Azure Synapse Analytics with AI, Tableau with Einstein Analytics, IBM Watson Studio, and Power BI. This means that we're not just looking at the data, we're transforming it into a valuable resource and gaining insights that can drive business value. By using a combination of data access tools combined with AI analytics tools, you can discover hidden patterns in your data and gain insights. You can automate routine tasks. For example, AI can be used to automatically categorize and archive data from legacy mainframe systems that reduce the manual workload for IT teams. We can enhance our existing applications with advanced AI capabilities like natural language processing to query mainframe data in plain language. For example, enabling business users to ask questions in natural language about inventory data and receive meaningful answers without needing specialized technical knowledge. AI can be the key for turning mainframe data into actionable insights, bringing new life to legacy systems. And next, we'll move on to a short demonstration.
In today's presentation, we will explore how to access and utilize legacy mainframe data using modern tools and technologies. We will start by discussing the use of COBOL copybooks and VSAM files, which are central to many mainframe environments. Then we will demonstrate how Connect's data dictionary serves as a critical tool for accessing and integrating mainframe data with contemporary platforms like Power BI. Additionally, we will showcase the power of AI-driven SQL generation using OpenAI's capabilities, bringing a modern touch to querying and reporting. This presentation will illustrate how these technologies come together to streamline access to vital enterprise data. Now we will transition to the demo portion of this presentation. On your screen, you can see COBOL copybooks for the 3 VSAM files stored in our mainframe. These VSAM files will be used throughout the demonstration. The files are connected by a relational structure. One customer can have many orders, and one product can appear in many orders. This creates a one-to-many relationship between customers and orders, as well as between products and orders. To access the data on the mainframe, we will create a Connect's data dictionary. This dictionary serves as our roadmap for accessing mainframe or legacy data. Connect's enables us to connect to over 150 different databases using this method. The first step is to initiate the creation of the Connect's data dictionary or CDD and name it. The next step is to select the VSAM COBOL FD files from the drop-down of the import type, and by doing so we will import the COBOL copybooks for the 3 VSAM files that I mentioned earlier. Next, we enter our mainframe hostname, username and password and the port. Connect successfully imports the COBOL copybook and creates a definition of the file. At this point, you are able to change a number of things. You can change the field names, you can change lengths, you can change data types, but 99% of the time the defaults that Connect allocates is probably the best value. Next, we will import the other 3 files and set up a connection to SQL Server, because we will be using both VSAM and SQL Server for this demo. The Table Indexes tab presents us information about the indexes that is inherited from the COBOL definition. Connect offers security at multiple levels. In this case, I want to secure this table definition of the file, the customer's file, for user SAG to only be able to do selects. So inserts, updates and deletes will not be allowed. One other feature that Connect allows you is to create a virtual view. You can combine 2 or 3 or more different tables and customize the view that a user could see. For example, in this case, you might not want the user to see the product price, but you want to see the orders and the products that are contained in the order without the price. And you can create a logical view and secure the logical view in the same way as we did before, but now you have the flexibility that the user can see only what you want him to see. Now that we have the Connect data dictionary created, we can access the data from tools such as MashZone in this case, or Power BI,
and create dashboards of data that is stored on the mainframe. Here is a dashboard created in Power BI, connects via an ODBC connection. In the same way, we can use Power BI to connect to our Connects data dictionary, which then connects to VSAM. As you can see on the screen, we have a Copilot icon that we can click. And since Copilot/Power BI knows what our table structure looks like, it suggests some questions, or you can even ask it open-ended questions. Here it's suggesting to create a new report about total customers. Once you select that option, Power BI goes away and creates this report for you of customers, and then which you can customize further. As you can see on this UML diagram, I'm going to use a different approach with artificial intelligence to query our data. In this case, we have a user that enters a natural language question to a Python application. The Python application then creates a prompt to OpenAI. OpenAI responds back with a SQL statement. The application then connects to Connects with a SQL statement, and Connects goes and collects the data from the mainframe, and eventually we return the SQL query and the data back to the user. To demonstrate this process, we have a Python application that will allow the user to enter a natural language question, which will then pass on to OpenAI that will generate the SQL prompt for us. The user is also given the file definitions or table definitions to help them with using field names or column names that exist. If the user asks a question that OpenAI cannot answer, we will respond back with an error message. It's important to note that OpenAI is not aware of our file structure, so we have to provide the roadmap or file structure to OpenAI so that it can formulate a sensible SQL query for us. In this case, our question was, show a list of customers that have orders for product ID 16. So this presupposes that the user is aware that we have customers and products and orders. If the user asked a question in a way that OpenAI could not respond, we would respond back with an error message. But in this case, we came back with a good SQL statement, and I provide the SQL statement back to the user for their perusal and the report below. At the end of the report, we provide the duration time of the OpenAI query and the SQL duration and the number of tokens used against OpenAI. Now we will try a little bit of a harder query. We want the product that sold the most or was ordered the most. We formulate the query and ask OpenAI to generate the SQL for us. After a few seconds, OpenAI responds back with a SQL statement and tells us that product ID 16, Pavlova, sold 286 units. The number of tokens used was 385 and the SQL time was 0.3 seconds. Now, just to double check that OpenAI hasn't given us a hallucination, we go back to the initial MashZone dashboard that I showed you. We select the product ID drop-down, ask it to show us all products that are related to product ID 16. On this screen, we show that all the orders for product ID 16 and the quantity. And if you add up all of those quantities, it'll be 286. So this is just another way to double check to make sure that your SQL was correct. So having this open-ended question allows users to ask all kinds of questions. There are no training wheels in this situation. So here we are exercising with a negative test. We are exercising our system and asking it to insert a customer. The response comes back saying, I'm sorry, but I can only generate select queries. And I will show you why that happened.
We have built two safeguards into our prototype system. One is we restrict operations to selects only for this user. So they cannot do any other operations but select. And in the prompt that we send to ChatGPT, we instruct it only to allow select operations. This is probably the most important part of the entire demo, is how do you interact with OpenAI. The first thing you note there is that I'm using GPT 3.5 Turbo. It's a bit of an older model, but it works perfectly fine for generating SQL statements. We provide a system prompt and a user prompt. The system prompt gives us instructions about how to structure and create the SQL query. I found a lot of these things out by experimentation, but as you can see, I've highlighted or bolded only generate select queries to prevent inserts, deletes, and updates. The second part is the user prompt, is the enter the user question, and we pass that on to ChatGPT, OpenAI, and it responds back with a query. As we conclude this demonstration, we've seen how traditional mainframe data can be seamlessly accessed and integrated using modern tools like Connects, Power BI, and AI-driven SQL generation. By leveraging COBOL copybooks, VSAM files, and Connects Data Dictionary, we've shown how legacy data can be unlocked for contemporary analysis and reporting. The integration with tools like Power BI allows for real-time insights, while OpenAI's natural language processing simplifies complex queries. This blend of established and cutting-edge technologies empowers organizations to maximize the value of the data, whether it resides on mainframes or in modern systems. Thank you for your attention.
Right, so as we conclude today's presentation, I would like to leave you with three key takeaways that encapsulate the value of using data access tools such as Connects for mainframe data access, analytics, and AI. First, overcoming business challenges. In today's complex and evolving technological landscape, real-time access and virtualization across multiple databases and platforms are critical for staying competitive. We have demonstrated how Connect enables this by allowing you to unlock data that is traditionally siloed in legacy systems and seamlessly integrate data into modern platforms without disrupting existing workflows or needing significant re-architecture. Next, meeting business demands faster. Oops, sorry, I forgot to advance the slide. My apologies. Next, meeting business demands faster. Speed is of the essence in today's business environment. By using Connects to access, integrate, and mobilize data across any connected source, you can respond more quickly to your organizational needs. Whether you're dealing with VSAM files or any other legacy or modern data source, Connects helps ensure that your data is not a bottleneck, but a bridge to faster insights. And finally, if I can get the slide to advance, enabling businesses to utilize data where they need it, when they need it, and with the tools that they're familiar with. With Connects, your legacy data becomes actionable for integration, analytics, and AI applications, empowering your teams to leverage this data using modern tools like Power BI, Tableau, or even OpenAI for query generation without the need of specialized training. In essence, we've showed you that you can future-proof your organization by transforming mainframe data. Instead of seeing it as a legacy challenge, you can turn it into a strategic asset. This asset becomes the bridge between your existing systems and modern data analytics and AI, driving your business forward. Thank you for your time. I hope that you are now as excited as we are about the potential to transform your legacy data into a valuable strategic asset. Now we move on to the question and answer portion of our webinar. Over to Becky.
Thank you, guys. Yeah, there are a few questions. And Demos, I'm going to throw the first one to you because you actually just answered it a slide or so ago, is can Connex access an IMS database?
Yes, so the Connex data dictionary that I showed you is your virtual view or metadata for a variety of different databases. Connex handles the underlying architecture. It is knowledgeable about what the legacy, for example, in my case, was VSAM, but we can connect to Adabas, IDMS, IMS, a variety of mainframe-based legacy databases, and virtualize those or present a view to the user as if it's a SQL database. So as Michael showed in his example, we see Adabas as a huge SQL database in the background from the front end. Connex handles the changing of the SQL query into something that VSAM understands, Adabas understands, IDMS understands, IMS understands. So in that way, you abstracting the technical complexity away from the user and you're enabling them to look at the data. One thing I didn't highlight specifically in my portion of the presentation was we have VSAM data on the mainframe for customers, and we have the products file on SQL Server. And we can seamlessly integrate those two into one query without having to be concerned about how VSAM works, how SQL Server works, how IDMS works. So it gives you that level of abstraction so that your .NET programmers, the folks who are more used to more current technology, are comfortable working in the mainframe environment, and you don't have that learning barrier between the technology that we're familiar with and comfortable with and have been using for 30 years and the technology that has emerged in the last, say, 10 years or so.
Okay, thank you, Demos. And you actually just answered the next question, is that can Connex be used to query data from multiple data sources or databases in a single query? And you just answered that, so that's good. Michael, I'm going to throw the next one to you. What does the deployment of Connex look like in your environment?
I'm happy to answer that. And I also notice that I think, I'm not positive, but it might even answer the other question that just got posted on what components get installed on Z. So we are a Z platform here in the state. We're an Adabas shop. Our entire criminal justice system, the system of record is Adabas. So what the installation looks like is we have a component on our mainframe running in the Z environment that is the mainframe listener. And that's going to listen for the calls that come in from Connex, these translated direct calls that are going to go into Adabas. And in our environment, we're a Linux shop. We're a .NET Linux shop. We're kind of a unique shop in that regard. So we run all of our applications in containers, and those containers use Unix ODBC to speak with Connex. Connex has a lot of different adapters, one of which is an ODBC adapter. We chose that one because it works seamlessly between Windows and between Linux. So we can work in Visual Studio if we like on a Windows computer and write our applications and hit F5 and run it and see it work. Or we can deploy it in a container on a Linux server running Red Hat Enterprise Linux 9, and just as seamlessly it'll run. The Connex ODBC driver will handle taking in that ANSI SQL that you saw in Demos's demonstration and translating it into something that Adabas can understand. So yeah, that's what it looks like in our environment. I'm sure that in some of the VSAM environments, there might be some differences, but for us, it's pretty straightforward and pretty simple.
Bob, I'm going to ask you, do you have anything else you want to add about what components get installed on Z?
Sure. Yeah, and as Michael mentioned, there is the Connex listener, and while in their particular case it talks to Adabas, Can also talk to VSAM, QSAM, IMS, all the different data sources. So there is a small component, it's efficient. And what it basically does is it takes those requests from the client, whatever they are, whether it be an application or whether it be a end user tool, it handles those requests and translates that into the native understanding language of whatever that underlying data source is, and then does all the translation back into the appropriate, ASCII versus EBCA and those kind of things.
Okay, thank you, Bob and Michael. I think I'm going to throw this next one to Demos. How does Connex make it easier to connect to different types of data sources?
So the advantage is you only have to learn the tool once. You don't have to look at learning, this is for a new person, right? So you don't have to learn the underlying complexities of VSAM, for example, to write a front-end application in .NET or Python, which is my favorite language, Java, whichever language you like. So you can present one learning curve and one user interface to the user, to your developers, and they have one way of communicating with 150 plus databases. So that's from a management point of view, or from a what I call programmer quality of life point of view, or developer quality of life point of view. I think this is a good way to go forward, that you are teaching folks only the things that they need to know how to get to the data, and they look at the data as a SQL server. But the underlying complexities in Connex, and the engineers that develop that have in-depth knowledge of all these variety of databases, Postgres. So if you're running DB2 on a mainframe under the Linux partition, you're running VSAM, you're running Adabas, they all seamlessly appear as if they are a SQL resource living somewhere in the ether, in the cloud. So, and then you can combine them as your needs develop. Say, for example, you're finding out that it's very expensive to run queries on the mainframe, but you have certain key data on the mainframe that you don't want to replicate elsewhere, but you have a lot of transactions that are living in a different system in, say, Postgres. You can combine those two without any issues, that they seamlessly appear as if they one database to the developer or to the user, or someone using a dashboard like Power BI or Tableau. So the main point to take away from that is that you're abstracting the complexity away, and in my opinion, delivering good quality of life to your developers.
Thank you, Dimas. Michael, this next one's for you. Can a non-mainframe person manage and work in this environment?
Absolutely. I mean, so, I have mainframe experience today, but I did not start, my career with mainframe experience. And, I myself manage a lot of the data dictionaries that my team uses. And a couple other team members have learned it and picked it up along the way. And they manage their own data dictionaries, some of them without any experience working with the mainframe. It's a very simple thing to do. For us as an Adabas customer, we just have a DDM reference that comes from Natural that basically just defines what our data looks like. We feed it to the data dictionary tool, and then we pick out how we want to represent our data through a nice little user interface. And we build that representation and use it in our applications. We tend to, when we're developing applications, kind of have a universal everything kind of view of things. But then as we go to production, we pare things back and pare it down to exactly what is needed for that application when it goes to production. So it really can only access what it's supposed to be accessing. So it's very, very simple to use for non-mainframe people, even management.
Thank you, Michael. There's another question coming in. How do you approach a performance issue that may have come from the SQL implementation in the LLM? Bob, do you want to tackle that one?
Sure, absolutely. There is a tool just like with normal SQL, it says, tell me what I'm actually translating this to and underneath. And typically what those performance issues are when you are doing things like non-key searches, doing inappropriate wheres, stuff like that. And the show the underlying transaction capability, in your test environment, highlights why that is. The other thing I really like about it, because it does this in chunks, it doesn't, let's say a user has a very bad query that says, I'm going to pull, 100 million records and all of the data for that 100 million records. The way that the Connect's engine works, it interlaces that with other demands. So it's not one long command. So while it might take that one person a long time to get that 100 million records, you're not actually stressing out the underlying mainframe. The other thing too that I like a lot, and we talked a little, just touched on it very, very briefly, but you can actually, as the developer, create what we call user views in the data. So that can ensure that the users execute the most efficient queries while still giving them the capabilities of doing, whatever they want, whenever they want. But you can force them to use the right keys, use the right joins, those kinds of things. So there's a variety of different ways that it handles that performance.
Okay, thanks, Bob. Hey, Michael, the next one's going to be to you because in Dimos's AI presentation toward the end here, he talked about, they were doing selects and they were rejecting updates. But do you, at the state of Delaware, do you find that Connects can process updates back to those non-relational targets easily?
Absolutely. So we use Connex in both forms. I would say we are a heavy read shop, but we absolutely do writes, inserts, updates in our application software, particularly when we do integrations. We do integrations with some external parties, and they provide us data when events occur in real time, and we will publish that data back over to the mainframe. Other circumstances might be, let's say hypothetically, you appeal some sort of an automated violation that you get for a traffic violation. We might go in and process an update on a record, on a court schedule or something like that to begin setting that process up. We can use Connex to do those kind of things just with normal update or insert statements like you would for anything else.
Okay, thank you, Michael. We have another question coming in, and it says, do you have this Connects in production environments on some financial bank customers? And actually, I'm going to answer this one. And the answer is yes, we do. This product is not a new product. It's been around for several decades now. And we have customers that range from financial institutions to commercial manufacturing to transportation like airlines, a lot of governments. Michael is from state of Delaware. It's in use in federal and state and local customers. So it's installed everywhere, and it is not a new product. It's been around for, like I said, at least 25 years, I think, if not a little bit longer. So so we do have a lot of production customers. The next one is, can you, and this is, I'm going to throw it to Demos. Demos, could you mention briefly in your presentation and your demo that Connects can work with analytic tools like Tableau and Power BI? Do you want to just expand on that a little bit more for our audience?
Sure, that's a great question. Michael referred to the state using ODBC connector. So with the folks, if you're familiar with Power BI, it allows you a vast number of ways to connect to data. We typically use the ODBC connection, but equally you could use JDBC, ODBC. So any tool, Tableau, Power BI, the Einstein, the IBM Watson tool, any tool that can access ODBC data source, you can get to connects, and then connects gets to the data in the backend. Now, ODBC is super efficient. I've been doing a lot of testing with it. I'm not going to say one is better than the other, but we found that ODBC works very, very well. I'm sure Michael would agree with that. We also do a lot of JDBC connections out of Python. I've connected to both JDBC and ODBC, and I found no performance difference between them. It's just that the connection grammar is a little bit different. But once you're connected to Connect, so Connect stands up a server in the background that then communicates with either the ODBC on your Windows system or a JDBC. It stands up a JDBC server by itself, which you can communicate with. But it removes that underlying complexity away from you. So to answer the question, any tool that can get to an ODBC data source or JDBC data source can access Connects, and then Connects, of course, accesses everything else. And then we build in various layers of security. Now, I know that Michael and at the state, they have the security at the source of the data, which is a very good solution because then you have one point of reference, but you can build security in various levels. So if you have a Tableau user, you only want them to see certain kinds of data, but not financial reporting data, you can define that in your Connects data dictionary and prevent them from looking at the data. So to answer the question, ODBC is a great way to get to the data.
Thank you, Dimas. And you actually answered the next question, which was about security. And we are running short on time. So I do want to thank everyone for their questions. Dimas and Bob have their contact information on the screen. And at this point, Janine, I'm going to turn it back over to you.
Great. Thank you, Becky. I want to thank everyone for attending today's webinar. I also want to thank Bob, Michael, Dimas, and Becky for sharing their expertise with us today. That concludes our webinar. Thanks again, and enjoy the rest of your day.